Hello everyone. Welcome to this video on binomial distribution. In this video, we are going to explore the fundamental meaning of binomial distribution and use it in solving some probability problems. Let's begin with the definition of binomial distribution. In that, first we want to know what is binomial experiment. So when we say binomial experiment, it is a probability distribution which has the following four characteristics. So for the binomial experiment or binomial probability distribution, the binomial experiment must have these four characteristics. The first one is the number of trials must be fixed. So when you're performing the binomial experiment, the number of trials in the experiment must be fixed. It can be like 7 or 8 or 10 or 27, but it has to be fixed. So the value of n is always fixed. Now, after you perform the experiment, you know that you'll have the outcomes. But in binomial experiment, there are two outcomes, and we say that it is either the success, which we say P, or the failure, which is 1 minus P, or simply written as Q. So each trial must have two outcomes. For example, when you're answering a true or false question, then you may get a right answer or a wrong answer. So you have only two outcomes. The outcome of each trial must be independent of each other. So the outcome of, for example, the sixth trial does not depend on the fifth trial, or the outcome of the seventh trial does not depend on the sixth trial. The trials are independent of each other. The outcome of each trial, they are independent of each other. The probability of success, P, or failure, Q, remains the same in each trial. If an experiment agrees these four conditions, then we say that it is the binomial experiment. The outcome of binomial experiment and their corresponding probabilities is known as binomial probability distribution. So if we calculate the probability in the binomial experiment, the outcome of the binomial experiment, and the corresponding probabilities, then it is called the binomial probability distribution. So for example, if x represents the binomial variable, okay, a discrete variable x, which is the result of the binomial experiment, and we have the corresponding probabilities P of x, then that is the binomial probability distribution. For the binomial distribution, the probability of exactly x successes in n trial, so there are n trials and there are x successes. We want to find the probability that you'll get exactly x successes out of n trial is given by this formula. Px, that is probability of exactly x successes, is equal to ncx, that is the combination of n taken x at a time multiplied to p to the x times q to the n minus x. So where ncx is the combination of n taken x at a time, p is the probability of success, and q is the probability of failure in each trial. We are going to use this formula to calculate the probability of exactly x successes in a binomial experiment, or in case of binomial probability distribution. Let's take an example and learn how to use this formula. Here is the example. Surgery at a hospital has 95% chance of success. So 95% chance of success, that is the value of P. So here your P is equal to, we can say P is equal to 0.95. That is the probability of success. So your Q, which is the probability of failure, will be 1 minus P, or 1 minus 0.95, which is equal to 0.05. That is the value of Q. So meaning of that is, if the probability of success is 95%, the probability of failure is 5%. The surgery is performed on 4 patients. So the number of trials is equal to 4. So n is equal to 4. and we are asked to find the probability of the surgery being successful on exactly 3%. So we want probability that x is exactly equal to 3 is how much? The probability of 3 successes out of 4 experiment is how much? So we need to find that. So let's recall the formula. What we know is this: probability x equal to 3 will be, okay, this was the formula for the binomial probability distribution. Probability of exactly x successes is NCX, combination of n, taken x at a time, p to the x, and q to the n minus x. So this will be, your n is 4, so in place of this we write 4cx. We are talking about exactly 3 patients. The probability the surgery will be successful on exactly 3 patients, so x equal to 3. So this x is 3, 4c3 times p is 0.95 raised to 0.95 raised to x is 3, times q is 0.05 raised to n minus x. N is 4, x is 3, so 4 minus 3 is 1, raised to 1. So if we simplify that, px equal to 3 is equal to, now we can simplify this using calculator. So let's grab our TI-84 calculator. Then we go to math, and then we scroll to probability, and we go to number 3 for the combination. So this is number 3, select number 3. So here we have 4, so that's your 4. On the other side we have 3, then we have times 0.95, so 0.95 raised to 3, okay, times, then we have the q value, which is 0.05 raised to, we have 1, and then hit enter, and you'll see that the probability is 0.1715. So this is 0.1715. So probability of getting exactly 3 successes out of 4 is 0.1715. Okay, we did this using the formula. We can also get this directly from our TI-84 calculator. In TI-84 calculator, we go to second and then vars. Then you'll see the distributions here. So scroll all the way down until you get the binomial probability distribution, BINOM PDF. That is binomial probability distribution. Hit enter. Then number of trials, we have 4 trials. Probability of the success is 95%, so 0.95, that's your p-value. X, that is the number of successes, the probability of number of successes that we are looking for is 3. Now paste this in the main screen, you'll get this. In some calculator, you'll just get binomial PDF, then you have to type this manually and hit enter. You'll get the same result, 0.1715. So in first case, we use the formula for the binomial probability distribution to get the value of the probability. In second case, we use the calculator to get the same result. So if you are using the calculator, make sure you write this equal to that so that I know you have used calculator and you got the result. So we write this as BINOM PDF from calculator. Then number of trials for 0.95. We are looking for 3 successes, so that is equal to 0.1715. That is by using the calculator, we got the value of the probability of exactly x equal to 3 successes out of 4. So in this example, we learn how to use the formula for binomial probability distribution to calculate the probability, and also we learn how to use our TI-84 calculator to find the value of the binomial probability using the function binomial PDF in our calculator. Now it's the time for the next example. Let's find out what is here. A survey found that 15% of the US adults say that internet is the major source of news for them. So 15%, you can see here, 15%, they say that internet is the major source of news for them. So here P is equal to 0.15. So you know the Q. So your Q will be 1 minus 0.15 or 0.85. That is the value of Q. Now you randomly selected 5 adults and asked them whether internet is the source of news for them. So you ask 5 of them, so you may get none of them, like 0 of them will say that they use the internet as the source. So it can be x equal to 0. So none of them use internet as the source of news, or one of them may use internet as the source of news, or 2 of them may use internet as source of news, or 3 of them, or maybe 4 of them, or maybe all 5 of them. So these are the random variable. The probability of these people answering yes is 0.15, and answering no is answering yes is 0.15 and answering no is 0.85. So you have always the same value in each trial. So this is the binomial experiment. So let me create the probability distribution for this over here. So when I say probability distribution, it is the random variable. It is the collection of the random variables in the binomial experiment and their corresponding probabilities P of x. So I want the probability of each of them here. So you already know how to find the probability using the formula or using the calculator. Okay, by using calculator, let's see how we get that. We go to second, then distribution, and then we go to binomial PDF down here. Number of trials here, we ask 5 of them. So 5. Probability that they answer yes is 0.15, so 0.15. And let's say x is 0. If x is 0, what is the value? So when x is 0, we got 0.4437. Now if this is 1, if that is 1, let's see what we get. If I change that to 1, okay, if that is 1, this is the probability. Now if it is 2, let's do the same thing. If I change the last one to 2, that is the probability. If it is 3, let's find out what is the probability. 3 of them, exactly 3 of them say that they use internet as the source of news. That is the probability. Now if I want to find exactly 4 of them say yes, the internet is the source of their news. That is the probability. And if we go to the last one, exactly 5 of them or all 5 of them say internet is the source of news. That's kind of unlikely, but let's see. Okay, we got 7.5937 e to the negative 5. Meaning of that is 0.40, and then in 5th place you have 7. And when you round this 75937, that should be 6. So we can write this number in our probability table here and complete that table. Okay, so this is our probability distribution. Now we are going to use this binomial probability distribution that is created here to answer these questions. So let's look at the first part, A. In first part, the question is find the probability that exactly 3 of them respond yes. Probability that x is exactly equal to 3. 3 of them respond yes. So exactly 3 of them respond yes. It is 0.0244. 0.0244. That is your A. In part B, we are asked to find the probability that at least 3 of them. When we say at least, that is 3 or more. At least 3 means 3 or more. 3 or more. That is the meaning of that. So we are looking for the probability that x is greater than or equal to 3. That is the meaning of 3 or more. So when I say 3 or more, in this table, it is 3, 4, and 5. So probability that x equal to 3 plus probability that x is equal to 4 plus probability that x is equal to 5. So that will be equal to probability that x is equal to 3 is 0.0244, then plus probability that x is equal to 4 is 0.0022, plus probability that x equal to 5 is 0.00006. 8. 0.00008. Now by adding this, we get 0.0267. That is the probability that at least 3 or more, or at least 3 of them respond yes, internet is the main source of the news for them. Okay, that is your B, part B. Now let's look at part C. In part C, we have to find the probability that fewer than 3. When we say fewer than 3, the meaning of that is less than 3. That is less than 3. So probability that x is less than 3. When I say less than 3, that is 0, 1, and 2. So this is probability that x equal to 0. So let me write this in next line. So this is equal to probability that x equal to 0 plus probability that x equal to 1 plus probability that x is equal to 2, which is probability that x equal to 0 is this value, which is 0.4437. Probability that x is equal to 1 is this one, which is 0.3915, plus probability that x equal to 2 is 0.1382, 0.1382. And when we add this, the result will be 0.9734. So probability that fewer than 3 of them answer yes will be 0.9734. So that is the second example in this video. Now let's talk about mean, variance, and standard deviation for binomial distribution. For the binomial distribution of the variable x, so if x satisfies the binomial experiment, the mean mu is n times p. So if we multiply the number of trials with the probability of success, that will be the mean. The variance will be n times p times q, or sometimes this is also written as variance or sigma is squared equal to n times p times q is 1 minus p. So we may write like that. And the standard deviation is the square root of this or square root of that, or square root of variance will give you the standard deviation. So let's take an example where we get chance to use these formulas. Here is that example. It has been reported that 65% of the adult age 70 and over got their flu shot last year. So P is equal to 0.65. That's your P. And if you want to get Q, So your Q will be 1 minus P, or 1 minus 0.65, which is 0.35. That's your Q. Okay. Now in a random sample of 200 adult age 70 and over, so N is equal to 200. We have to find the mean. We are looking for the mean. Then we are looking for the variance, which is sigma squared, and the standard deviation, which is sigma, for the number who got their flu shot. So let's work on this one by one. The first one is, let's find the mean. Mean mu is given by the formula n times p. N times p, n is 200, multiplied to p is 0.65. So 200 times 0.65 is 130. So mean, or the average number of adult age 70 and over who got flu shot last year, was 130. Next is variance. Variance is sigma squared, which is equal to n times p times q. So n is 200, p is 0.65, and q is 0.35. So if we multiply this, the variance will be 45.5. 45.5. So your standard deviation will be, standard deviation sigma is the square root of the variance, square root of n times p times q. But we have the value of n times p times q as 45.5. That is our variance, 45.5. And if we take the square root of 45.5, it is 6.7454. That is the variance. So in this example, we learn how to use the formula for mean, variance, and standard deviation of binomial distribution. This is the third and the last example for this video. Thank you so much for watching.